All right, students, we are on J4 today, so you should have your notebooks out. You should be sitting in your assigned seats. You should have something to write with. You don't need anything else other than a pencil and your notebook today. If you want to have Desmos out and ready, because we are going to be learning a new button on our Desmos calculator. Okay, so we're on J4 Permutations. This chapter is going to have 6 lessons in it total. So our goal is this week we are going to finish Unit J with our notes. So we have J4 today, J5 tomorrow. Remember, Wednesday is that weird day with e-learning if you're in 9th grade, 10th grade reading MCA, 11th grade is your math MCA, and 12th grade is e-learning day. And then Thursday you'll have a practice, and then Friday we'll do the J6 notes. And then next week we'll have a practice, a review, a one-pager, and our test. Our test is next Thursday, so on the week 3 Thursday. Okay, so we're doing J4 permutations today. And permutations is a listing where order is important. Okay, a listing where order is important. That important is really, really important because that is what is going to be the difference between what we do today and what we do tomorrow. So for some people, when they order their sandwich, they want their order to be exactly how it is with everything. So when they do, I want lettuce, I want cheese, I want, I don't know, turkey. They want to make sure that it's in that exact order. And when I get a sandwich, I don't care what order it is. That order does not matter to me. Okay. The way you get dressed in the morning might be a permutation. So you might put your pants on first, or sorry, you probably would put your underwear on first and then your pants, and then maybe your socks, and then your shirt. You probably wouldn't want to put your pants on and then your underwear. That wouldn't work. Okay. And really when we think permutation, a big part where it matters is if you're putting like your password into your phone. That's going to make a really big deal. Okay. All right. So the way that we write this is we write a lowercase n, uppercase p, and a lowercase r, parenthesis. And then we're going to write n, and then a comma, r. Okay, now this n and this r are going to be replaced with numbers. This whole thing is the symbol that we use in our calculator to identify this. So n is our total objects. And r is the amount that we need. Okay, and that's what we're going to be using this whole time. Now, the way we say this is different. The way we say it is a permutation of n, and then we use this word choose, r. So we put this word choose in there because it tells us how many we're picking out of the n. So we're starting with a certain amount, but then we're only picking another amount. So n choose r. All right, the way that we do this is different the way we do it in Desmos. So we're going to talk about how to get this into our Desmos calculator. Our first thing we're going to do in Desmos, I'm going to pull up my Desmos here. Give me 1 second. Okay, so in my Desmos calculator, we are going to, can you see that better or worse? I can't tell. I'm at home, so I think it's better that way. Okay, so what we actually do is we hit this func button, F-U-N-C, which stands for function. Okay, so right here is the func button, F-U-N-C. So we're going to hit that func button, And then down here in the corner is that NPR. Okay, so we're going to go to the function menu. And then we hit that NPR. Okay, now especially if you're using your Desmos that's on your computer, for some reason it doesn't let you type, which is really annoying. So then you're going to go back to the main to get back to the numbers. Okay, so we go back to main. And then we do a number, and you do have to type in comma number. Okay, so I'm going to show that again on Desmos. Okay, so on Desmos, I'm going to go to the function menu, which is right here, this FUNC. I'm going to hit that NPR. I need to go back to main, and then I'm going to do number, comma, number. So like 12, comma, 3. And we would say a permutation of 12, choose 3 is 1,320. There's 1,320 ways to order 3 numbers from 12, or 3 items from a group of 12. Okay. All right, we're going to do 2 examples. Our first example is just going to be an example of going through how to talk about this and making sure that we understand the total and all of that. The second one we're actually going to do probability with. So here we go with example 1. We're going to talk about an attendance award, which we usually do in the spring here. Hasn't been announced yet, but maybe there will be. So attendance award. We did one with the no phone February, right? Okay, where we did awards. We're going to give awards to first, second, and third place. Okay, now when we get awards, it matters who's first, who's second, and who's third, especially if the prizes are different. Okay, so as we take a look at this, we're going to say that there was 5 freshmen who get this award, who earned to be in the drawing. I'm going to say that there's 9 sophomores. Three juniors. And we're going to say there's no seniors. Womp womp. All right, so what we need to do is in our permutation here, we need to figure out our total objects and the amount that we need. So we need to find N and R. So N is our total. So for our total, we're going to add those up. 5 plus 9 plus 3. Which if you need a calculator, that's fine. So 5 plus 9 plus 3 is 17. So 17 students are up for the award. Okay, but how many are we picking? We're going to pick just first, second, and third place. We're picking 3. Okay, so in our calculator, we're going to put N, capital P, lowercase r. Oops, I don't want an equal sign yet, sorry. Parenthesis, we want our total first, so 17, comma 3. Okay, so I'm going to enter, so I go to my function menu, NPR, back to my main menu, 17. Now the comma is right here next to the parentheses, 3. Okay, in parentheses, and I get 4,080. Oops, you can't see that. There you go, 4,080. Okay, so there's 4,080 ways that we could do first, second, and third place just with 17 people, which seems like a lot to me. Okay, we're going to do one more problem. This time we're going to do one with some probability. Okay, so we're going to do number 2. We need to just move up a little bit. There we go. Number 2, we're going to talk about an iPhone passcode. And we're going to do 4 digits. And because we're keeping this, remember, unit J is our basic probability. When you do our advanced probability, we'll go into the repeats, but for basic, we're going to say no repeats. Once we add in that repeats, it turns into a bigger problem, which we will do next chapter. This chapter, we're going to keep it simple. Okay, now remember, and we want to know what is the probability that if I randomly pick a passcode, it starts with 3, 6, something, something. Okay, so to start, we need to figure out our total sample space. So our total passcodes in general with 4 digits. So because it is digits, because it's a passcode, the order matters. So we're going to use N, P, R. Now we need to figure out how many digits do we have total to use. Let's see if I can get my phone to do this. There we go. Okay, so on your phone passcode here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's actually 10 numbers because we have that 0. So we have 10 numbers to choose from, and we are going to pick 4. So I'm going to put that into my calculator. Okay, it's kind of nice. I got that NPR from the last one, so I don't have to retype it. 10, 4. We get 5,040. So with no repeats, there's 5,040 total ways to write a passcode using just the normal 10 digits. Okay, but now I want to know how many ways there are if it goes 3, 6, and then something, something. Okay, so we have N, P, R. Now for our first number here, I already used 2 numbers. So originally we had 10, so I'm thinking 10 minus 2, because I can't use those numbers anymore. Okay, if I go back to my iPhone, trying to do this without it noticing my face. There we go. Okay, we already used 3 and 6, so we can't use those anymore. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, originally we needed 4 spaces, 1, 2, 3, 4, but 2 are taken. So I can think 4 minus 2, or just 1, 2 spaces, so 8, 2. Okay, throw that into my calculator. All right, I'll show you that NPR one more time. Remember, you hit Func, that function menu. Down here at the bottom, NPR. Go back to main. We're doing 8, 2. We get 56. There's only 56 ways to fill in the rest of that passcode. All right, so now to find the probability that we do 3, 6, something, something. We want how many ways did it work? It worked 56 ways out of how many total? Our total is 5,040. Okay, now we're going to throw that in the calculator, see if it simplifies. 56 out of 5,040. Okay, as a fraction, it does simplify to 1 over 90. Write that as a decimal. So 0.0111111. Put that repeat sign over that 1. Okay, and if you're not sure what that is as a percent, we can always type in times 100. We get 1.1%. So if you are guessing someone's passcode and for some reason they don't have any repeats, and you guess 3, 6, you only have about a 1.1% chance of somehow getting it right, or 1.1% chance that you even guess the first 2 right. It's kind of crazy. Okay. So in your quick check today, you're going to be doing problems like this, where you're just typing it in. You're going to be doing problems where they give you an amount, and you have to figure out the N and the R. And then you do have a couple problems like this at the bottom, where they're giving you an idea. First, find the total. When it says total, that means without the probability, just the original amount. And then you're finding it with those parts sticking out. And then the probability. All right, you got it.